And if n is greater than l, this turns out to be an. So max is equal to n, so which is true. So yeah, this is actually true. So you verify it, and using that single line, you can see how you can finally got back to that smallest point, and then you did one line solution of this instead of doing the epsilon delta. And now use a sandwich theorem to get this point, get this equation. Okay.
Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning. How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number two, we help you prepare and ace your entrance examinations in statistics and data science, like IIT MS, ISI MStat, and CMI MSc Data Science. Number three, we give our absolute best to help you design your career by organizing workshops and certified data science courses.
Essentially, I'm trying to understand what is this, how much, what is this value. This value is nothing but this protrusion is nothing but the l, how much is deviating from l. So it's n minus l, the length of that, plus l. Now the whole sequence, the good part is that this is going to 0. This protrusion is, you can see this length is decreasing with time. So observe that the max of n comma l, if you want to use algebra, so there are two cases. N is less than equal to l and n is greater than equal to l. If n is less than equal to l, of course you know that the max will be less than equal to l. But if n is greater than equal to l, then you know that max is nothing but n, which you can write that the protrusion length plus l. Right? Now what I am doing is that I am combining both of this to make a single number. That is, this is also less than equal to, what I'm doing is that I'm adding l plus certain length. So I am seeing that one quantity is working from one side, another quantity is less than that quantity, kind of thing, the modulus of that quantity. So what I'm doing is that I am doing this max is less than equal to the modulus of this quantity plus L. Now, for this case, for max for n less than L, the max is less than L, which is less than equal to this L plus certain positive quantity, right? This is always positive. Mod is there. And in this case, this is nothing but n minus L, because n is greater than equal to L plus L. So we have these two things. So therefore, together, we can write that this is less than equal to mod of an minus L plus L and greater than equal to an. This is what I have done. The idea came from the idea of protrusion. You can see the length is decreasing, the protrusion. So I want to measure the protrusion, add it to the actual length. Now, the maximum protrusion length for even for this is less than equal to L. What I did is less than equal to an minus L plus L. So which is certain quantity of it. Like, so basically I did this. I just transform the negative into positive. So like this. What I assumed is that if I reflected that here, if this is going to 0, if n is going to 0, then if you just take this, oops, I cannot take that. I just took this and rotated it here and reflected it here. This also should go to 0, because if n minus L is going to 0, then mod of n minus L is also going to 0, right? The length. And I just use that here. The good part is that mod of an minus L is less than equal to, like, an minus L is less than equal to mod of an minus L, right? So I wrote as an is less than equal to L plus mod of an minus L. So the question is this true? The answer is yes. Because if n is less than equal to L, then of course this is something plus L. So of course this is true. And if n is greater than equal to L, you see that that is equal to n, right? Now this is interesting. So if n is greater than L, this is the length of the protrusion, like how much is going above, and plus the limit. So this is cancelling out, it's n. And if n is greater than equal to L, greater than L, then of course maximum is equal to n. So this is equal to n. But if n is less than L, you know that maximum of n comma L is less than L, right? Because the maximum is less than L. less than equal to L. Now, of course, you know maximum is less than equal to L, which is less than equal to what? L plus something positive, An minus L. But the good thing is that An minus L, this thing is going to 0. That's what I'm using now. So I have got now a sandwich theorem out here. Now if you apply the limit, yes, and this is something I learned right now, that yes, using a single An, you can use sandwich theorem by transforming it a bit. So you have two different sequences out here. And An minus L, this goes to 0, hence this goes to L, and this goes to L, hence this goes to L. All of you understood this? It's beautiful. And if N is greater than L, this turns out to be An. So max is equal to N, so which is true. So yeah, this is actually true. So you verify it, and using that single line, you can see how you can finally got back to that smallest point, and then you did one line solution of this instead of doing the epsilon delta. And now use a sandwich theorem to get this point, get this equation, okay? Got it, guys? Yes or no? Did you understand this? How to solve a problem step by step.
To book a trial class for your preparation courses of IIT MS, ISI MStat, and CMI MStat Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.